Okay, we will continue our video on the most recent Anki deck. I believe this is about intermolecular and intramolecular forces as well as thermodynamics. Basically anything under general chemistry 2 that is introduced in grade 11, second semester. Okay, so this is the zeroth law, thermal equilibrium. So this basically describes a situation where there is no net heat flow between two systems. Eventually, two systems or two objects would reach that point once, let's say, two objects are different temperatures, and they would eventually meet um, a common temperature. So that's exactly what's manifested in the stated example. Next, the higher the temperature, the faster the particles move. And when the temperature goes up, the kinetic movement goes up. It's already been stated in the previous vid. You've already seen this as well. Just citing the video before this, because we've already tackled, I believe, most of the flashcards in this deck in that video. Super critical, no, super saturated. Yep, super saturated solution. Endothermic and exothermic reactions. Endothermic is the absorption of heat. Exothermic is from the prefix exo, exit of heat. Simple covalent molecules have a small fixed number of atoms. For giant covalent molecules, from the adjective giant, so they have large and variable number of atoms. So small and fixed go together, large and variable come together as well. A triple bond contains 3 pairs of electrons, or in other words, 6 valence electrons. So 3 pairs, 1 pair for each line, that is equal to 2 electrons each pair or each line. So 2, 4, 6, 6 electrons in total. Okay, it's already been mentioned in the previous vid as well as this. Higher concentration means faster. No. The amount of solute is high in the solution. So there's more salt compared to solvent regarding their proportion. For lower concentration, it means there's less salt or solute in the solution, there's more solvent. So this is from gas to liquid. Evaporation is from liquid to gas. Freezing. Third law. This has also been mentioned also. Intermolecular forces, the 5 types. Ion dipole being the strongest, London dispersion being the weakest. Intermolecular forces are forces that attract molecules together. So we're talking about bonds in between the molecules. For intramolecular forces, we're talking about the force or the bond within a specific molecule, not in between two molecules. Okay. First law. This is the first law of thermodynamics. Heat is a form of energy. Therefore, as subject to the law of conservation of energy, heat can neither be created nor destroyed. It can only be transferred from location to location or converted from form to form. So let's say in a boiler we have heat energy. It's converted into mechanical energy through a turbine, and it's converted into electrical energy as it's transferred into a generator. So that's it. 5 types of intermolecular forces. Intermolecular forces versus intramolecular forces. For intermolecular, they are forces that exist between molecules. For intra, within a molecule. So holding atoms together. So there are atoms in a molecule. Yeah, that's it. A double bond contains 4 electrons or 2 pairs. So For each line, there is one pair. One pair is 2 electrons. So 2 lines, 2 pairs, we have 4 electrons in total. Okay. Enthalpy, H is equal to U plus PV. U is what? The heat supplied to gas increases internal energy. Internal energy, I think that's what U is here. Pressure times volume plus pressure times volume. What is the main definition of enthalpy? Just to be safe, let's search it now. A thermodynamic quantity equivalent. Let's just search it here. Enthalpy. The measurement of energy in a thermodynamic system. Okay. Pressure and volume are indirectly proportional or inversely proportional. So if there's higher pressure, we have lower volume. That's why they're being multiplied to each other. And we add that with internal energy. Okay. Specific heat. So this is the amount of energy in the unit calorie or joule added or removed to change the temperature. So specific heat capacity, on the other hand, is, well, basically the larger the specific heat capacity of a substance, the less its temperature will change when it absorbs a particular amount of heat energy. So in a way, it takes more time to it takes more time to change the specific heat capacity of a substance. So this is the formula. Heat over mass times change in temperature. Okay, that's it for this video. Thanks for watching. I'll see you in the next one.